Chapter 10 is different to some of the other chapters we've learned in Algebra 1. We're focused mostly on graphing data and analyzing data sets. In this first section, we're really going to focus on a lot of vocabulary, different measures of center like mean, median, and mode, and measures of variation like range, how spread out data are in a data set. So let's jump right in and look at how we calculate mean, median, and mode. Mean is really just another word for average. So to calculate an average, you need to sum all the data points in a data set, and then you divide by the number of values you have in that data set. So if I look at this set of students' hourly wages and I want to find the mean or the average, the first step is to add all the values that I see in the data table, in the data set. And if I add all these values together, those sum up to $77.20. So I sum all the data together, and then I divide by the number of values I actually added together. And there are 8 hourly wages listed in this table, so I'm going to divide by 8. And when I do the division, I get an answer of $9.65. So the average hourly wage for these students at the amusement park is $9.65. Median. For those of you learning to drive or have just kind of paid attention, median in kind of everyday non-math speak is like that kind of island of grass in the middle of the road that separates the northbound traffic from the southbound traffic. That's called the median. Median means middle. So in that example, it's the middle of the road, and here we're talking about the middle number in a data set. So if you want to find the middle number in the data set, you have to list all of the values in order, lowest to highest. And this can take a bit of time for larger data sets. Fortunately, this data set is only 8 numbers long. So let's see, $8.25 is the lowest number. And there are a couple of those. And then 8.45 is next, 8.25, you do list each 8.25 separately because the number appears twice. Then we've got the 8.45. Then 8.65 and 8.75. 8.65, 8.75. Then we've got $9.10, $9.25, and the $16.50. So we've used up all of those values now. To find the median, we want to find the middle number. Since there are 8 values, there is no one middle number. Numbers 4 and 5 are kind of both in the middle. And when that happens, if there were an odd number of values, I would just pick the middle number. But here, because there's an even number of values, I take those 2 middle values and I average them. Remember, an average is just, 8.65 plus 8.75. This time I'm only averaging 2 values, so I divide by 2. And that gives me an answer of $8.70. And so you can see you could have really done that in your head without actually doing the calculation. But $8.70 is the median value for this data set. The mode. Perhaps you've heard, again, a non-math use of this word. Mode just means fashion. And the fashionable number is the one that appears most frequently in the data set. And so if I look at this data set, and it's easier, again, if the values are listed in order, it's easier to spot those repeat values. My only repeat values are the 8.25 that I had in the very beginning. And so that 8.25 is a repeated value, so that is my mode. $8.25 is the only repeated value. Okay. There can be no mode in a data set. If everything just appears once, every value just appears once, then there would be no mode in the data set. It's also possible to have more than one mode. If 8.25 had been repeated and $9.10 had been repeated twice, just with 2 repeats, then they would both be modes. but if there's one mode, it's the one value that's repeated the most. All right. Which measure of data best represents, which measure of center best represents these data? If I look at these data values, most of the student wages are kind of in the $8, $9 range. But there's this one kind of standout, noticeable higher pay. So all 7 of these data points are below $9.65. Even my $9 wages are at like $9.25 and $9.10. They're not as high as $9.65. This one high value for the hourly wage is really skewing my mean. The mean isn't a good measure of the center of this set of data if it's really skewed like that, where there's this one value that's super big. If 7 of my data points are below $9.65, then the mean is not a good measure of center. The median, on the other hand, is a good measure of center, because it's right in the thick of these values of the majority of these hourly wages down here. $8.70 is, well, in this ordered list of hourly wages, I can see that $8.70 literally is halfway between the smallest value and the biggest value. And so that does seem to be a good measure of value. The mode, that repeated value, is at the really low end. So 8.25 seems way too low to really represent the center of this data set. So we would say that the median is the best measure of center. Median is best. The mean is higher than most of the data. And we see that the mode is lower than most of the data. So let's focus on that $16.50. There's a word to represent an unusually high or an unusually low value, and we call that an outlier. And so that $16.50 from this data set is the outlying value. It's unusually high. And the next question is asking us, well, what happens if we remove that outlier? What happens if we take it out of the data set? What happens to my average? And what happens to my median? So kind of what happens to these measures of center? So let's look at that. How does this affect the mean? Well, remember when I added up all the values before, all 8 values in the data table, it added up to $77.20. But now I'm not going to add in that $16.50. So I'm going to kind of subtract that one outlier value away. And because I do that, I'm not going to divide by 8 anymore. I'm only going to divide by 7 because my data set only has 7 values in it now. So when I do that, I end up with $60.70 up top divided by 7. And so my new average is $8.67 is my new average, my new mean. And if I compare that to what I had before, sorry, my 7 there doesn't look very much like a 7. If I compare that to the value that I had before, I had $9.65 before, and now I have $8.67. So my mean decreased by 98 cents. Okay. So in this example, by removing this really high outlier, I did decrease my mean by a substantial amount. Let's look at how the mode is affected by removing this outlier value. So this median now, looking at this list, because I've already written it in order, it's a little easier for me to see what happens when I remove that outlier value. Now I have an odd number of values in the data set, and my new median is $8.65. So, what was the effect of removing this outlier? Well, my old median was $8.70. My new median is $8.65. And so the median decreased by 0.055 cents. So when you remove an outlier value, the median also changes, although by a lesser amount than the average changed. The next step is we're going to look at how did removing this outlier value change the mode. And in this example, if again you look at this original ordered list, there was only one repeated value. It was down here at the lower end, and those were not outliers. We did not remove them from the data set. So the mode is actually exactly the same as it was before. My only repeated value is $8.25. So there was no change in the mode. Okay. So when you remove an outlier, you usually affect the mean the most. You affect the median less, and you affect the mode less. And in this example, not at all. Lastly, because this is a real world problem, and all of these kind of statistics data set questions are real world problems, thinking about an explanation for that outlier. Why are most of these students getting paid around $8, $9 an hour, but one student is getting paid $16.50 an hour? Well, one possible explanation for this is just that student is doing a bigger job. Perhaps they're a manager, and so they get paid more. Perhaps they, manage all of the park attendants who work on a ride. So that would be one difference. Maybe they have more responsibility, like they are responsible for building the website for the company or something like that. So we could have a bunch of ride attendants and then one manager or one website manager, something like that. Um, all right, let's look at another set of data. And this time we're going to look not at how we measure the center of the data, but how we measure kind of the spread of the data, how spread out these data are. We're going to do this by looking at the range of the data sets. So the range, to calculate the range, you just do the highest value minus the lowest value. So if we've got two reality cooking shows here, each has 12 contestants, um, and I want to find the range of ages for each show, then what I need to do is I need to find the highest age and the lowest age. 19 seems to be the lowest age here, and 31 is the highest age here. So the range for show A is going to be 31 minus 19, which is 12 years. And for show B, I'm going to do the same thing. I'm going to look in this list for the lowest age. This is the only one that starts with a 1 in the tens place. And then show B has an older contestant. So the range for show B is going to be 48 minus 19, which is going to be 29 years. So what this tells us, this asks us to kind of compare our results. The range of ages for show B are going to be greater than the range of ages for show A. These show B is more spread out, and this has less spread out ages. Okay. What happens if we have a data set and we want to transform the data set? We want to change every value in the data set by a certain rule. We're going to go back to the first data set that we were looking at in part A, those different students getting paid different amounts at the amusement park. And we're going to pretend that they're going to get a raise. And the boss is looking at two possible ways of giving raises. They're going to either give every employee a $1.25 raise per hour, or they're going to increase everybody's wages by 10%. So we want to look at what this does to the distribution of hourly wages and kind of what changes happen to the data set. So first, let's look at what this $1.25 increase will do to the mean. Okay, so the average. Remember before, our original average was $9.65. And now we're going to add $1.25 to every single value in this data table. And you can actually pause the video and do this and go ahead and add $1.25 to every single pay wage up on there and calculate the new average. But there is a shortcut. And when you're talking about measures of center, if you're adding the same value to every number in the data set, then your measures of center are going to also increase by that same value. So if my original average was $9.65 and there's a $1.25 increase, then I'm going to add $1.25 to that average, and my new average is going to be $10.90. If, on the other hand, we talk about a 10% raise, what will that do to every value in my data set? Well, when you multiply every value in the data set by the same number, you take your measure of center and multiply it by that same multiplication factor. So if my original average was $9.65, I'm going to take this and multiply by 10%. Now, I'm going to do this kind of wrong, and then I'll do it the right way. A lot of times students look at this, they're like, okay, it's a 10% raise. So let me multiply this by 10%. Remember, 10% is the same, percent means out of 100. So 10 out of 100 is 0.1. So they take this 9.65 and they multiply by 0.1, and that gives us 0.965. Does this answer make sense? 96.5 cents. Is that the raise? Well, 96.5 cents is less than the original pay, is less than that original amount, $9.65. What this is this is the raise amount. This 96.5 cents needs to be added on to the original $9.65. So I still need all of that original $9.65, but I have to add on the 96.5 cents. And then all together, that gives me $10.62, rounded off. Okay. Now, there's a shorter method for doing this so that it's not a two-step process. Instead, I can take that original $9.65, and instead of multiplying by just 0.1 to represent that 10% raise, I multiply by 1.1. I want all of the original $9.65. I want 100% of that original $9.65. And then in addition, I want that extra 10%. And so by doing this way, you get the $10.62 in one step instead of doing it in two steps. It's quite common for students to forget that and just multiply by the 10%. Just look at your answer and think about whether your answer makes sense. And if you forgot to multiply by 1.1, if you multiplied by 0.1 instead, make sure to go back and add that value to your original average. This strategy for these measures of center, this doesn't just work for the mean, the average, it also works for the median, and it also works for the mode. If you're talking about a dollar increase or a value increase that you're adding to every number in the data set, you just add that same value onto your mean or your median or your mode. And if you have a percentage increase, if you're multiplying every value in the data table by the same amount, then you multiply your mean, your median, or mode by that increase value. All right. Which increase results in the greater range? And this is for our 1.25 increase versus our 10% raise. Our original value from the previous page was the range was $8.25 because we had 1650 was our biggest value, 825 was our smallest value, and 1650 minus 8.25 gives us 8.25 as our original range. Okay. And then we want to see how this changes. Remember, in this first example, we're adding k to every value in the data set. So what happens to our measure of variation? What happens to this range? Our range doesn't actually change. For this $1.25 increase, where we've added $1.25 to every value in the data table, the range is still the same. The new range is still $8.25. And if you think about it, that makes sense because I added $1.25 to the 1650, and that gives me $17.75. And I added $1.25 to the $8.25, so that made $9.50. And if I do that new subtraction, I have the exact same range that I did before. So if you add the same k value to every number in the data set, your range doesn't actually change. On the other hand, if you've multiplied every value in your data set by the same value, this does change your range, and you multiply your original measure by that k multiplication factor. So as we said above, we end up multiplying all of our values by 1.1 to represent that 10% raise. So if I multiply $8.25 by 1.1, that gets us $9.07.5. So kind of rounded off is, $9.08 for our new range. So you can see that the range of values has increased with this range. Because each student's wage went up by 10%, the high-paid students' wages went up more in dollar-wise than the low-paying student wages. So if you look at that, the 1650 number times 1.1, that highest paid student now gets paid $18.15, whereas the lowest paid student, that $8.25 student, if we multiply that by 1.1, they now get paid $9.07.5. So the lowest paid student, their wages went up by less than $1, and the highest paid student, their wages went up by more than $1. And that's what causes the range to kind of increase in size. So you've got some general rules here for helping you know how to manipulate data sets if there's some sort of change, like adding a value to every value in the data set or multiplying every value in the data set. I hope this helped.